I was going to say, everything has been so slow lately. All right, so for today's opener, let me turn the light off just so we can see, and I'll turn it back on. Choose a separate grade. Since you're doing it together, it should be a free 100 unless you choose, just like not listen. All right, so there are 3 types of nuclear decay that we talked about yesterday. What are they? They have names. What are the 3 types of decay? Alpha, beta, and gamma. So we've got, I'm going to put them up here. So we've got, I'm hoping it's going to let me write on it. So we've got alpha. Okay, so this is alpha. And we've got beta. And then we've got gamma, which if you can't like draw that, you can just write like a Y. It's fine. That's basically what it is. So what is an alpha particle? How do we represent it? You remember? This is not part of the question, but I'm going to put it up here anyways. We represent it, not just a little fishy symbol, like it actually is something. What is given off by a nucleus that is the alpha particle? What is actually emitted? Not hydrogen. Helium. Okay, so, and then what were the numbers? 4 and 2. Okay, the top number is the total change in mass, and the bottom number is the change in protons. Okay, and you're reducing with this. What was a beta? Not helium, what's a beta? The E, and it's a 0 and it's a -1. Okay, and if you have a beta particle, that means that the mass doesn't change, but the number of protons is actually going to go up by 1. Okay, and then what was a gamma? Yeah, so line with the 0, 0, which is pure energy. Okay, so what are their masses equivalent to? An alpha particle is a helium nucleus. That's an E. What does the E represent? Electron. And so what the heck is gamma? Because it's 0, but it's still emitted. So what is it? You don't know. This is pure energy. It doesn't have mass. It's pure energy, which is why this is the most damaging. If you come in contact with gamma radiation, it's going to kill you. I'm just saying. You would protect yourself from this one with a few, like about 4 inches thick of lead or multiple feet thick worth of concrete, which is what we do with nuclear reactors. What do you protect yourself with? A beta? Paper. No, paper's alpha. Beta is stronger, so it's something between paper and lead. We said wood was in the notes, but I always taught it that it was aluminum foil. I think that was a ding on the people meet. Nope, maybe not. So now all that stuff is messed up. So let me, when I switch, I've learned when I switch my slides that it does that. So the 3 types of decay are alpha, beta, and gamma. The alpha is a helium nucleus, beta is essentially an electron, and gamma has no mass. That's their masses. Alpha is He with a 4 and a 2. You are reducing the parent by that. Beta is an E with a 0 and a -1. You're increasing only the protons from the parent to the daughter. And then a gamma is the Y with the 0, 0, and you have no change. It's the same element. Now, we're going to go over the stuff that I don't know what I did with my clicker. Sorry. I just literally watched the documentary all of my break. All right, so if you go into Canvas, there's this exit ticket. So, and I know they can't see. Oh, all right, I don't know what you guys see in grades, and I don't want that going on to YouTube. If I go into chemistry. Okay, so in Canvas, come on. It's so slow. It's thinking. All right. There is this exit ticket. So if you guys would click on that, we're about to go through this together. This is a grade. This is basically a free 100. So go into Canvas, go into the module, and click on the types of radiation exit ticket, and it should pull up this. And periodic table. Because this is, now the assignment that goes today, this is basically how you do the back. Okay, the front is like vocabulary, but the back is which one is it? Is it alpha, beta, gamma? And how do you figure out what the missing substance is? Okay, so letter A, first of all, what type is it? Is it alpha, beta, or gamma? Alpha. How do you know it's alpha? This thing right here. This thing right here lets me know that this is alpha. I'm just going to write that. I'll go ahead and write it out. Because we're using Greek letters with this. Okay, so I am starting off with Pu, which is, let's see, number 94. That's plutonium. What?
What is this on?
This is in Canvas. This is the exit ticket in Canvas. That is a separate rate.
Oh, that's not paper.
I don't have a paper version of this. I have a paper version of that one. I don't have a paper version of this one. Okay, so does alpha reduce the parent or does it increase to the parent? It reduces. So what is 242 minus 4? Okay, so we know the top. Oh, this is going to be hard for me to fit in there. Well, I'm going to try. So we got 238, okay, and then that's an 8, by the way. That didn't help. And then we're going to do 94 minus 2, which is what? So how do I know which element this is? How do you know it's uranium? The atomic number is 92. It's for an alpha, that's all you have to do. Well, there's one on here I haven't shown you how to do. We're going to skip that one. All right, so for letter B, first of all, what type is this? This is a beta. And you know that because of this. Did they put the one with the neutron on here? Please tell me they didn't. Good, 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 good. All right, so now this means that the sulfur has one more proton than this guy. Okay, so what would the bottom number be? 50. So you got it right. So, which is phosphorus. So what is the mass number? 32. Because there's zero change in it. $252 to 259. Well, this is the opposite direction. We're not doing this one. It didn't teach you how to do C in the notes, so we're skipping that one. That's totally different. All right, so we're gonna go down to D. So you're going from 26 to 25. 55 is the same. So if there's no change in the mass, and there's a change of 1 with the protons, is it alpha, beta, or gamma? This is also beta. Okay, so that means that I'm missing the electron with the 0 and the -1. I should be doing different colors in here. No, I'm not sure. I've never even done that one before. I don't know which one that is. All right, so now I'm having, this is also beta. Okay, and so you're going to have 15 is going to be the same. And you're going to have 9. And so which one is it? Chlorine? So there's no gammas that are on here. I really don't know what letter C is. I've never seen that before in my life. But if you have one that's gamma, such as uranium. Oh, I'm sorry. Oh, okay. So if you have one that's in gamma, which I'm going to do on the board, like uranium. So uranium-238. And it's at what, 92? Y'all may need to pick up another periodic table if you don't have one. So it's going to change to 238.92. This is what happens in a nuclear reactor. This is what gamma radiation looks like. These numbers don't change. Pure energy does not have mass. It's pure energy. If you have a beta, then it's going to be this guy. If you've got an alpha, it's going to be this guy. I'm going to erase the ink off this side. But yeah, You don't do it?
How'd you break it?
How'd you break? Now, this is, like I said, this is exactly what the other paper is, and if you want the paper version, I make the paper version. If you try to do it digitally, you can. But you really have two things that you should be taking a look at. There's this one, which I gave to you guys yesterday, and if you didn't do it, then now you get 2 assignments. We just did this one together. So, like on the back, on the back, the example of gamma radiation that I see point blank is number 9, and that's how you're supposed to draw the weird Y thing. But today is to let you be able. I haven't even made a key. I need to do that to be able to work on this. Really, this should not take that much. So you're telling what the missing thing is, whether it's one of these or this one, or you're actually calculating what's missing in the blank. That should not take you that long. Over here is it alpha, beta, or gamma. That's it. And like I said, we're skipping C because we're not. Let's see if I can figure out what this one's supposed to be. 98 to 103 is, that's a difference of 5. Yeah, I don't know what that one is. Ignore C. I'm going to have to ask Youngman what the heck this even is because I've never seen it before. Californium to Lawrencium. Yeah, 1, 2, 3, 4, 5. That's a jump of 5. Ignore it. But like I said, you have the period to do this one. And then I know some of Castleberry's students got through this real fast, and some of them did not. If I show, do you need me to freeze this so I can go into something else? Yeah, yes? Okay. Because if I unfreeze it, all of that stuff is going to vanish. Okay, I got it. Do you understand what this, how to do these? You can't, I know you can't spit, you can shake your head. Okay, hold on. You're going to ASL. Okay, so let's, who else? Bailey. If you understand what's going on, yes, you can go. There you go. All right, now if I go back to, my eyes feel like they have ants crawling in them. Oh, yes. As long as you're using that one, you're not walking around. All right, let me go to back into Canvas. If I go back, I'm gonna drag my Canvas over. Why didn't it not drag? Okay, so in Canvas, there's that gallery walk assignment, and when you click on it, hold on. Alpha is the one you can block with paper. Beta is either wood or aluminum foil, and then gamma is either lead or like multiple feet thick of concrete. So if you did not look at the gallery walk thing from yesterday, which is still open, the top link is the slides. Okay, and then the bottom link is this. So, I mean, if you're doing it on paper, you can just use this and follow along with it. Otherwise, you're going to have to be like open up 2 tabs and you can just go back and forth. Everything is so slow. But it says the pros and cons of nuclear chemistry, and it just does each one. It starts with Chernobyl, and it goes to 3 Mile Island. Oh, that was the year after I was born. I thought that was the year before I was born. The Fukushima one, the one that had the tsunami, the Japanese thing with the nuclear reactor, you may remember that. That's in there. Hiroshima, when we dropped the bomb on Japan. Nagasaki, when we dropped the other bomb on Japan. Well, we're the only country that's ever dropped a nuke on another country. like an atomic bomb nuke, not just like a nuclear, like a little, like the big bomb. There's one on carbon dating. There's one on nuclear submarines. There's one on nuclear power plants. How it's used in medicine, how it's used in space. Okay, so there's one for each. It's one slide for each. You do not need to write me paragraphs. If you write big, you might want to use a separate piece of paper. Just saying. So that's what y'all are doing today. Tomorrow, we're going to go into nuclear energy, fission, and fusion. I won't be here Monday, so I'm going to let you work on your assignments that are still open Monday. I'm going to go back and double check and make sure that these dates, like, will let you do them through Monday. I'll probably do that here in a second. Tuesday, we'll do radiation and living things. Wednesday, there will be a Google slide that does all three, sort of like a review. We'll actually review for the Unit 12 test on Thursday. Then your Unit 12 test will be Friday, and we are essentially done. I will give you a list of what I'm looking for in your notebooks. I'll probably have a link for that for you guys on Monday. I mean, you won't have all the notes to be able to submit yet, but if you've been writing them on paper, you probably want to start taking pictures and emailing to yourself, putting those JPEGs into a file to get ready to submit it because your notes are test grade. Let's see, we're an even class. That last week of school, notebooks have to be completely submitted. I need to check them by the beginning of the period Monday to make sure that none of you have like forgotten to give me access. Or maybe you just sent me one thing and not the entire folder. I get that. Tuesday should be your, if I'm remembering, I think Tuesday's odd and Wednesday's even, I think, because it's not on the highlighter. And then Thursday's the half day, which is like makeup for CBAs, which you guys are the only class on this campus. I don't mean just this class, period. Chemistry is the only class that has official CBAs. Everybody else got to make their own because they hate us and we do not know why. But that's what y'all are doing. Let me stop this.